Hello, this time we will try to perform assembly language programming on STM32CubeIDE. We have done it with Kyle in previous videos. Now we're going to do it for STM32CubeIDE in case if you want to do assembly language programming on this along with the C programming. So let's see how they coexist. Actually, it's a good idea to test that out. So what we do is we first call STM32CubeIDE. You have to first download it from its site, and then you have to start it up. Now I have it on my screen. Now what we're going to do is first we're going to start up a project, file, new, STM32 project again, and we make some initializations on the STM32 target selector as seen, and we're going to be selecting our target from this screen. Okay, so in the board selector part, make sure that you enter your own board. Mine is Nucleo F303RE. Click that and make that your favorite project, make favorite device rather. Click on next and give a project name. My new assembly is your project name, for instance. Use the default location, no problem. Target language is C, and binary type is going to be executable. Target project type is going to be empty. So select empty over here, and then click finish. So this opens up a new project file with all these folders underneath. What we're going to be concentrating on is the src. It's going to be main.c. It's basically empty for now, and we're going to be using it empty also. So we'll have a while loop that's going to continue to call an assembly file, assembly procedure rather, over and over again in a for loop. So this is how the interaction is going to work for us. We will have a startup file. As you see, we have a startup file which is ending up with the device name .s at the end, as you see here. You can use this as is because it initializes all these parameters for you. So you don't have to do anything, you shouldn't have to do any modifications actually. So what I'm going to do is I'm going to implement my code here that I have already written earlier. So I'm going to be writing that into my main.c. You can do the same. It's basically a while loop. Let me just magnify it for you. A while loop with an empty assembly file. While loop with an assembly file that you're calling over and over again. And make sure that you declare this assembly main as an external, so that when C is compiled, it knows that the assembly main is somewhere in one of those folders that you can link it, so that does not give you an error. Okay, you're fine. Let me get back. Now I'm going to be also creating another file here, which is the assembly program. So it's going to be new file from a template. So you use a template from an assembly source file. Default assembly template is a good idea. So you apply and close. Give it a name, just main assembly.s is the extension. For assembly files. It's just going to be another assembly empty file. Let me bring my code to here as well. Just paste it. Now let's go over this code. So it's basically a file that initialized at the top as a Cortex M4 CPU, and it's a dump instruction content, and it has the following assembly main as a global function. So assembly main, basically the first thing you do is push the LR value into the stack, then you recover at the end with a pop PC, so that when you come into this procedure you can get back to the main program. In these kind of procedures that you have nested calls, the LR content gets lost, so that you have to save this value and you have to retrieve it with a pop BC at the end. So what you do in this code is basically you have to start up a GPIO clock in the initial case, and then when you initialize it, you have to refer to a reference manual for that device that you're using. So for your specific device, this GPIO clock can reside in somewhere else. So make sure that this address is correct. Just check out RCC AHPENR register is in this location or in a different location. You just have to plug in your R0 value. Whatever that value is, you have to plug it in here. You get the content from that location into the R1 register, and then you better modify it here and then you store it back. If you don't do that, if you just modify, or if you just get that value and then modify and destroy the other contents, that might harm whatever that is going throughout the whole GP or any clock process. Actually, you're modifying the content, so it's not a good idea to do that on any register. Just get that value, modify it, and then store it back, and modify only the content that you want to modify, such as here. So it's going to be the first value is going to be shifted 17 times. That value is going to be modified by ORing that content with that one in this position and storing back. Similar arguments go with the GPIO motor part for PA5. PA5 is my LED up, so your LED might be residing somewhere else. So please make sure that your LED is in that position, in the fifth position. So how is it going to affect your code? Well, you're just going to be modifying a different portion of your register. So this 5 has to be replaced with whatever PA5 you have. So you're accessing port A and you're reaching the fifth location. These are in pairs, that's why you have to multiply by 2. And then when you reach that position, you're going to clear the content of 1 1 in that position. So 3 is 1 1 basically in binary. So you're clearing that content in the 10th position. And then you're setting that content to 0 1 in the 10th location and storing back. Now once you have done this, you have configured your PA5 as an output in GPIO A motor. So after that, you have to turn your GPIO on and off, as you see here. So you again reach the ODR register for GPIO A, and this is in this location, 48000014 location. You get that content, you set that content in the 5th position because you're going to be modifying the 5th bit position, and then you store it back. How you set it? You OR it with that with your previous value in that 5th position, and you do the similar thing in the LED off operation for the same memory location. That's why I don't modify the R0 value here. I use the previously defined R0 value. I get that value, I clear that value this time. I don't OR it with 1. I clear that value in that position. I bit clear that value. I store it back. And in both cases, I have to give a delay between those blinking of LEDs. So I do a BL delay after each of LED on and LED off. This has to be a decent amount of duration. So my delay subroutine over here basically is initiated from starting point of R2 600,000 and then decremented at each iteration by 1. As you see, subtracted, you subtract 1 from that value, and then it is run until it is not 0. So branch not equal. That means if you don't have a 0 flag, just stay in the loop until R2 is 0. So once it's 0, you go back to your calling program with BXLR. You have 2 calls, one from here and the other one call is going to be from here. And after all this is finished, you pop it back, pop your PC back, and you go back to your main call. So let's see how it goes afterwards. If everything is okay, then this is going to compile fine. Make sure there are no other open projects, so make sure all the others are closed except your own project. So that's going to be my project. So I build my project. I do a build all, and I have no errors, indicating that my code has compiled fine. And I have to do a run afterwards. I have to reach to my device. Make sure your device is connected at this moment to your USB, and then make sure you don't have anything funny with your debuggers or startups. Just click OK here and make sure your code is downloaded into your device. So it's blinking right now, it's just being downloaded. And as you see, the green LED started blinking. It has been blinking because I have already run this before, but it is blinking right now. You can change some parameters here in the code, such as make this blinking run much faster. So let's do it 6 times faster by decrementing 6 to 1. I do another project build. Of course, you have to do it all the time, and you have to do another run to download it onto your device again. So let's see if this LED is blinking faster in this case. As you see, it's much faster. Okay guys, so this is the code. Make sure that you have these 3 files, main.c, an assembly file that you're calling, that you can reach from main. Make sure they are declared as extern in the main and the global in the assembly code. And make sure you have a good startup file that works along with your code. So that's all. Have fun with your projects. See you later.